Thank you all for coming to this session on heat pumps. We put kind of a negative spin on the title. Why did these projects fail? But obviously, what we hope you leave here today with is some answers to why they fail and what you can do about it to help those projects be successful. If this is one of the first sessions you've come to, I'll just quickly introduce myself. I'm Brad White. I'm on the editorial board for automatedbuildings.com. So hosting all these sessions, but in my day job, I'm actually a consulting engineer in Vancouver, and we do an awful lot of heat pump projects, mostly retrofits, a lot of recommissioning. We walk into a lot of buildings that have had heat pump for 5 years, and it's never turned on, and they've only been using the boiler. And we spec a lot of heat pumps, and I deal with a lot of suppliers and distributors, and have had we've had a lot of successes, but I've also had a lot of experiences where, to give you a couple examples, I've got a cut sheet that says 135 leaving water temperature, and then the tech gets to site and says, well, best I can do for you is 125. Otherwise you're going to strain the machine, and then startup is the first time I'm hearing that feedback. Or I've got not meeting my set points, and I've got 2 out of 4 compressors on, and I have no idea what I need to do to get the last 2 compressors to come on to give the full capacity of the machine. And nobody else seems to be able to tell me either. So these are the sorts of experiences I've had. I know talking to these guys, it's kind of industry-wide, and looking at how full this room is, I think there's a lot of interest in this. So let's get to it. We're gonna run through each of these gentlemen here. They're going to tell you who they are and give you their perspective on this topic. I want this to be a really interactive session, so keep your questions handy, because we're going to go to questions, pretty much as soon as they're kind of done going through their pieces. We can start doing some questions. I've got questions. I think let's have a good discussion here. So without further ado, James, why don't you start us off?
Hello, my name's James Murphy, and I work for Long Building Technologies. We're temperature control and equipment rep in Denver, Colorado, based, and then we kind of handle most of the West. I have about 30 years of experience in heavy equipment, coolers, air handlers, that kind of stuff, as a sales engineer for consulting engineers. Heat pumps are kind of taking over, and we all run into issues almost on every job, and we learn as we go. You could call it like heat pump university. It's not working. Sorry about that.
That's better.
Can everyone hear now? Once again, James Murphy, and we have heat pumps on almost every project now in Colorado, and every project we're learning on, I call it heat pump university. We're paying the tuition each job. But the big things that we run into is a lot of times we try to push the machines to their absolute limit. We try and get the most hot water out of it we can, operate it at the coldest temperatures we can, get the biggest delta T's at the lowest flow rates, and we're really pushing the envelope of the machine. And we really have to work on, trying to do everything, you accomplish nothing, and really kind of try and get them into their sweet spot so that, over the years, we had 80 years to perfect chilled water and boilers, chillers and boilers, and we don't have a lot of the problems they had 80 years ago because we've learned. We have to learn those heat pump tricks to keep them running the majority of the time, because yes, they can do it, but is it reliable? Is it consistent? And that's kind of one of the things we always run into. And we are going to talk about kind of some of our strategies that we use. We say kind of get it into its envelope, give me as much volume as you humanly possibly can. Maybe the variable pumping system you have needs to be evaluated. And then the other thing is we have to communicate from the get-go with the end user really how the system's going to perform. So we want to really set the expectations early that this is a great system. It might not save you money, but it'll definitely reduce your carbon usage. And that's the real goal, right? We want to reduce the amount of carbon we use. And in some places where you have dirty power, you might not save as much carbon throughout the whole year. But if you look at the carbon reduction over the year, that's kind of what we have to talk. So we have to set the expectations. We have to kind of really not push the units harder than we should. Other than that, I think we can talk about the individual stuff as we go on.
Yeah. Who's responsible for making sure you don't push it harder than, like, because that happens, right? That happens all the time. Like, what's the breakdown? Why is that happening?
A lot of the breakdown is because there's not an abundance of information from any manufacturer because we're moving at lightning speed. And then the other thing that happens is we run a selection at max capacity, max flow, but we don't look at any of the part load performances, or we're moving fast or anything like that. So I would say it's everyone on the team that has to be involved. Of course, the manufacturer, of course, the rep that you're working with, the consulting engineer, and then the other consultants that are involved. Like if you have a loop consultant that's doing your ground loop or doing the sizing of ground loop, if they're not talking with the equipment manufacturer from the get-go, you're probably going to run into some problems as well. So it's a team effort. It's better to get everyone on board early, but definitely manufacturer's rep and consulting engineer really have to work hand in hand.
I have lots of questions, but we'll save it till we get through. So Dan.
Dan Gentry. I'm an applications engineer for Trane Company up in La Crosse, Wisconsin. Born and raised in La Crosse, raising my family there. It's a great community. If you don't know what an applications engineer does at Trane, really, we consider ourselves systems folks. So we help design, layout, control, troubleshoot systems as a whole. So we have a good understanding of the various products that we have, but we try to look at the really system holistically. And me personally, I'm primarily focused on hydronic systems. So like our team has air side people and we have water side people. I find myself on the water side. So a lot of chiller plant configuration. So making a determination of, are we gonna do variable primary flow? Are we gonna do decoupled pumping? What are the implications from efficiency, control, operations for all those different kinds of considerations, let's say. The past, I'd say most of my career, I've been heavily involved with heat pump and heat recovery applications, again, on the hydronic side. So, like small dedicated heat recovery chillers, air source heat pumps, 6-pipe chillers, 4-pipe air source heat recovery chillers, all the like. And so that's what I do. So it's really helping customers, talking with consulting engineers, talking with our account managers in the field to really navigate those systems questions. On top of that, our group also creates a lot of literature for the industry. So like application guides, application manuals. If you're familiar with engineers newsletters, that's like a white paper. We do engineers newsletter live, which is a produced video on just various industry topics, just primarily for educational purposes. I've been in this role about 5 years at Trane. Before that, I was in our centrifugal product support group for a few years, so a lot of familiarity with our large centrifugal chillers. Before coming to Trane, I was at Multistack, a modular chiller manufacturer, for about 8 years, where again I worked in product support, supporting modular chillers, heat pump and heat recovery applications. So a lot of, equipment history in my background, and now focused on equipment in systems.
So after, having been at Multistack and now at Trane, like you've got a perspective that goes beyond one product line. Are there common things you see as the point of failure in some projects?
Yes, I would say it's a lot of times it's going to be system related. So like, how are the pumps controlled? How is the bypass size controlled? Where is it located? We were talking about loop volume on the side over here. I would say those consistencies have remained the same going from manufacturer to manufacturer. Obviously, each manufacturer has their own nuances with the equipment or with the controls or whatever that looks like. But a lot of those system level issues persist.
I can see we're going to be pointing a lot of fingers at the consulting engineers. It's all right. All right, Matthew.
Hi, my name is Matthew Smith. I'm with Air Treatment Corporation out of Brea, California. I come from a perspective where I've worked for manufacturers, Trane.
Sorry, just maybe speak up a little. Thanks.
I come from the perspective where I have worked kind of all through my career at manufacturers, and now I'm on the rep firm side. So I see it from both perspectives. My take on why heat pump fails is that during engineering design, we don't have enough people understanding how the logic works with internal components. With the chillers, I think what we try to do to make our project successful is sit down with the design build engineer. We go through sequence of operation, hydronic layout, and we look at the whole system, and then we try to give them really good information to base their design off of. I have a lot of experience in control sequencing, so writing a good control sequencing is only as good as your mechanical design and vice versa. So looking at that from a perspective. Also, bringing just the knowledge of working on a lot of products. So going from multi-stack, water furnace, JCI, YMAE, Quantec, QTH1, you get to see a lot of different internal workings, but understanding how compressors stage, variable speed, single circuit versus tandem circuit. So there's a lot of things that we need to understand about the equipment before we apply it into a system.
That's great. All right, because I'm standing at the podium, I'm going to take the liberty of asking a couple of questions that I want to hear about first before we open it up. But actually, show of hands, how many consulting engineers do we have in the room? Okay, quite a few. All right, good. So I guess my first question is, I'm reading between the lines, subtle and not so subtle. If the engineer is making bad decisions about where to put that pump, how to sequence it, do you guys push back? And do they listen?
Yes, maybe, and no.
Yeah, I would say there's a common theme out there that primary, secondary is the easiest loop, but when you apply with modular chillers, your modular chiller is always chasing the secondary load. So you have to come with very complex sequencing to manage that. So I think engineers, I am a believer in keeping things simplistic. Like, let's keep them as simple as possible, have as much loop volume as possible. But pumping sequencing is very important.
Well, and I think it was Matthew, when we were having our sort of prep for this session, I think mentioning that you were seeing some issues with people kind of being over-reliant on ASHRAE 36.
Yeah, definitely.
Well, do you want to talk about that a little bit?
Yeah, so I study the guidelines, the codes. We operate in California. We have a lot of silly laws out there. We have issues with flowing through dormant heat exchangers. We have to be able to keep system minimum flow. That's a challenge with that law. ASHRAE 36 was built based off more of a chiller plant and a boiler plant, and we're adding sequencing into our sequence of operation that is shutting off the chiller off of zone-based demand, and depending on how your internal logic works with the chiller, you're throwing alarms all day long because of that, right? So we need to think about letting the chiller stage off by itself. So letting it meet set point, letting it, if it's variable speed, slow down, try to maintain set point. If the load diminishes, then let it stage off and sit idle. Like, we do not need to be resetting these things every 15 minutes. That is silly, and we should just not be moving in that direction. So people writing codes, in my opinion, on ASHRAE 36 and Title 24, how many hours have they spent with the top 4 manufacturers in the room discussing how the internal logic works? And I know the answer is 0. So let's get in front of our application engineers like Dan, and that know how exactly the internal logic works, what staging the chiller is going to make, and let's get a code that's going to work for the equipment.
Do we have anybody in the room on the ASHRAE 36 committee? Yeah, no, that's too bad. We had somebody here earlier who was.
I wanted to add to that because I think that's a really good point, and it gets to the controls, as we had talked about how controls plays into this. I've seen now enough jobs where I've seen the control systems actually disable the heat pump once the heat pump made the set point. Like, they make the set point and shut the thing off and then turn it back on and have to wait for everything to stage up, which is just, insane to think about a control system that would do that. But I think it does come down to the consultant not understanding the internal logic of the machine, whereas generally speaking, for the most part for these machines, you enable the machine, you give it a set point, and it's going to make the temperature that you're asking it to do. And you don't have to do anything else to mess with it. You let the unit controllers control the heat pump how it was designed, and just let those sequences play out, and it's generally going to...
So you're saying we should not operate heat pumps like we do atmospheric boilers?
That is correct. Enable a heat pump and give it a set point and give it the appropriate flow rate, and it will do what it's supposed to do. But when you start trying to control a heat pump and mess with it, that's when you're going to start to introduce trouble.
And to kind of go back to your question about, do they listen? I think the consulting engineers in today's market are put in an incredibly difficult position. I think a lot of times they are given an edict from either the AHJ or from the state that they're in saying it must be this, and not really any direction from them on how to accomplish it. And the challenges we face in Denver are real. We have very cold temperatures, high altitude, so air source heat pumps are a real struggle for us, but we're supposed to be all electric, and our heating loads are way more than our cooling loads if you look at it an annual basis. And so then now the consultants like, here, don't use gas, and no real roadmap. So do they listen? They want to listen, but they really don't have a choice. So we have to get everyone at the table from the AHJ down early on if we're going to tackle these, and you have to tackle it in a local market because each local market is different. So if there's rules, we have to get them changed or get stuff changed so that the engineers can listen more and be able to really find the sweet spot for each climate zone you're in. I think it's super important because sometimes the answer is your annual energy use. Going back to Colorado, we have dirty enough power that if we drip below about 2 COP on our heat pumps, we actually are putting more carbon in the atmosphere using a heat pump than we do natural gas because of how we generate power. And so is a dual fuel or something to bridge the gap in a market like Colorado important to do, because the overall goal is your annual carbon footprint. That's what we want to reduce, and we can reduce it drastically using a heat pump in Colorado, but there's times where we can reduce it more if we maybe switch over to a natural gas boiler and do both. I know it's a little off topic, but I think it's important to know that the consulting engineers are in a difficult spot because we've painted them into a corner. And we really need to help them across the industry to get to where we can deliver quality projects.
I mean, yeah, we do a ton of hybrid or dual fuel systems. We do a lot of retrofits, so it's often not practical to have heat pump do the whole thing.
How about another point to that, to the hybrid systems, is where you place the boiler in the system and how you stage the boiler on the system. Because the last thing we want to do is be running our boiler when we could be running our heat pump. And I was just looking at a job last week where they had it piped such that it was heat pump or boiler, but with some thinking through the piping, you could use your boiler to supplement the heat pump or just use the boiler if you couldn't use your heat pump. So configuration and controls are also really important when you're mixing various pieces of equipment together.
My advice, if you're retrofitting a older system and you have a central plant and you have a boiler system, place your heat pump sidecar return to return. We see a lot of applications where they want to go return to supply. It affects like main loop delta T, and that's not what you want to do. You want to have return to return. We've had a lot of success with that.
Amen.
All right. So we've talked a bunch about this kind of design considerations, how to get those right. I want to talk about commissioning for a second, because that's the other area we see a lot of projects fall apart. You've got everything. You've done the right things with your hydronic design. You've talked to you guys about a sequence of operation that actually is going to work, and we get to commission it, and it kind of goes to hell at that point. So what are your tips for commissioning? How do we get the commissioning piece right?
I would say I've had a lot of projects with heat pumps that have been 5 years of commissioning because the turnover takes a long time. I would say when you get into a think room the first week, you probably came up with the solutions. Don't spend the whole 5 years of going through the process of proving it, because I could give an example on a project I was working at. We needed to move the hot water bypass more down into the system, not right at the chiller plant, adding buffer tanks, rewriting the complete sequence of operation, because we had burn mode, we had charge mode, we had DX mode, and everything we came up with in the first week took us 5 years to implement, right? So just kind of getting in there, having an open mind, talking it through, looking watching, listening to the chiller plant operate, and then making your judgments after that.
Anybody else want to add something?
I think another thing is too that startup is not commissioning. And that's a big thing we have to make sure to separate, because startup in my mind is a technician going out, making sure wires are tight, the program is in, the machine is ready to run. It may have some initial set points put into it, but it hasn't been run through its paces. Whereas, commissioning is running it through its paces. And I think, like with, in my opinion, with heat pump projects, especially air source heat pump projects, you're going to want to do seasonal commissioning, because I want to see what that does in the spring, the summer, the fall, the winter, because the performance of that piece of equipment is going to be different in all those modes, and the flows may be different. So
and that wasn't true of boilers. Like boiler, run in January, run in November, it's the same, right? Heat pump is not an air source heat pump.
Yeah, the boiler would run a little dirty at different times, but whatever.
Yeah.
I think the other thing we have to think about is what is the goal of commissioning, right? Are we trying to keep the building so that you hear it all the time? I spent this much money on my HVAC system and it doesn't work, right? Well, it does work. It just trips every third Tuesday or whatever. And the problem with that is a lot of times we're trying to push the commissioning into optimizing every ounce of energy, every ounce of carbon out of the job, right? We're trying to save everything we can. And maybe we need to relax that a bit, become a little more flexible, and really try and get a system that's a little more robust and can run. And so you'd set it up differently during commissioning if the goal is to get a system that every time they show up at 8 o'clock in the morning, their building's warm and everything's happy. Or do we really want to say we're going to squeeze every ounce of energy out of this building that we can? It's two different things, and I don't know if we're quite there yet, squeezing every ounce of energy and getting a very reliable building.
I was going to say, I always say, before we talk about optimization and efficiency, the system has to work first. So working is the first thing, efficiency is day two.
Yeah, well, that's we've got a whole session on commissioning tomorrow, by the way. If you're interested in commissioning, you should come, where we'll talk a lot more about this kind of thing. But like in our practice, because we commission a lot of these systems, and we've I like how you kind of described it, Dan. There's startup and like the functional testing, making sure the equipment will turn on, produce hot water. But then like that optimization piece is a whole, we call it performance commissioning. And it's usually, but performance doesn't just have to be low carbon. Performance can be, my building is warm at this time of day. It can mean, energy use, it can mean car, it can be all kind, but you have to define those boundaries, what you're trying to achieve, right? And only then can you then start the process of actually achieving that. And I'll just give a quick plug for any of you in Canada. We've just, I think 2 weeks ago, released a new version of the CSA commissioning standards, Z5000, Z5001, that we just rewrote to add performance commissioning with some specific considerations for heat pump systems and dual fuel systems. So if you're in Canada, I would encourage you to check those out. They're on the CSA website. But yeah, I think we've been talking a lot. Questions? Anyone want to jump in here? Yeah. Might have to yell. There's a mic. Actually, you know what? Just 3 seconds. A mic is on its way to you there.
My name is Andreas Pasas. I'm from ACI Mechanical in Seattle. So I think a general theme is you've got to keep it as simple as possible in relation to the controls. Give it a set point, give it a flow, let it do its thing. It was mentioned earlier that I think the argument was that primary variable might be better than primary secondary. But I wonder if it's maybe the opposite, where primary secondary is better, because primary, you can have the primary pump dedicated to the heat pump, give it a constant flow, make sure it's happy, whereas the secondary loop pump can just keep the secondary loop happy and modulate to the load. So I'm just curious takes on primary, secondary versus primary variable.
So in California, we have a code that says that you do not want the secondary loop out pumping the primary loop, okay? So we have to have 95% of flow on the secondary and over pumping by 5%. So I guess my question back to you is, if you have terminal units that are starving for a bunch of water, how do you accomplish that?
If you're saying if the load is too high?
So if you look at a building and how it operates, the chiller plant and the terminal units don't talk to each other, okay? So all we know is we have an air set point that we need to reach in the building and a chill water valve that's reacting to that, or a hot water valve that's reacting to that. So if you control your pump, your system pump to system DP in this scenario, when you open a chill water or hot water valve, your pump's gonna speed up because system DP drops. Well, in modular application, you might be running one module and you just added 4 modules worth of flow. So how do we accomplish that with only having one module running? We have to let the temperatures run away on the primary side to actually start to stage up the heat pump. So also, a lot of engineers will state that you could use your system as loop volume. All you could use out on your secondary loop is your bypass for minimum flow for the pump. Everything on the primary side is gonna have to have a buffer tank for that loop volume.
Yeah, which I would completely agree with that. Yeah.
I was going to add to that question, though. That's a good point, and I say it's also the determination of variable primary flow or decoupled pumping could also be driven by the equipment type too. Like take a packaged heat pump that's not modular, so it doesn't have the valves in it. That may just be a constant flow system. I can think of our package unit we see, you can probably do a 15-degree delta T through the heat pump. So if you have a 20-degree, 30-degree delta T in the system, you can't do variable primary flow, and there's flow limitations on that heat exchanger that would rule out variable primary flow as an appropriate as an option for pumping configuration. So understanding the equipment type, modular valves, and what the minimum flow is for a packaged piece of equipment will determine if it's a candidate for variable primary flow or if you should consider a different configuration.
Great, thank you.
Question here.
Hi, I'm Craig Sylvie with ACO Engineered Systems. We're a design build mechanical contractor out in California. Thanks for this. It's a great topic. First, I had a comment about as far as, agreed, it's important for design engineers, design the systems, understand the inner workings of the heat pumps. I feel like maybe there could be more information available to us, so that would be greatly appreciated.
Thank you for bringing that point up.
Yeah. I had a specific question. We all recognize loop volume is important, so now you're introducing buffer tanks to the system. The question becomes, where do you put the buffer tanks? Seems to have been consistent advice on the chill water, put on the return. Now where do you put it on the hot water? You've got defrost to consider on hot water, so we've kind of seen two camps, one saying, well, put it on the supply to buffer those drops in supply temperature you might get, or another saying, no, you still want to put it on the return to protect the equipment. It's curious your guys' thoughts on that.
I would say I'm traditionally like buffer tanks on the return side of units. And my thought process is we have a nice consistent return water temperature for the chiller. The chiller controls, does its thing, and it makes the leaving water temperature that it's supposed to be making. With air-to-water heat pumps that are subject to defrost, our current recommendation is if you're concerned with the effects of defrost, put that buffer tank on the supply side. So now you have a warm tank, and then when the unit goes into defrost, runs into the buffer tank, and that, say, dampens the effect of defrost before it gets out to the system. That's what our recommendation is. I think you could debate the merits of one or the other. I don't know if there's a right or a wrong way to do it, but whatever you're trying to protect, maybe the equipment or defrost, whatever it is, that would, in my mind, guide you towards where you would potentially want to place that tank?
It also would depend on the equipment too, because your defrost mode might not even be anywhere close to the delta T that you would. And so if your tank's running at 120 degrees or whatever, you might only lose a few degrees and the building can roll through it. So the return might not be a bad idea, but I think the equipment is probably, it's dependent on the type of equipment you have and how much defrost goes in.
I want to just pull on the other thread that he brought up about information being available to consulting engineers, because that's something we've experienced, right? Is especially on the control side, and during the commissioning phase, troubleshooting. I get the. I think in my intro I brought it up. A position where we only ever see 2 compressors come on out of 4, and it's not making supply water temperature. I'm not equipped to troubleshoot that with the information available as the commissioning engineer in the project. But anytime I go talk to my rep, I get sales talk back. Like I can't get through the layers I need to get to you guys, the applications engineer or the controls guy at the factory who actually knows the answer to my question. And I know it sounds like you guys are doing a great job with this, but I tell you that's not the case everywhere in the industry. And so what do we need to be doing different there to allow everyone to get the information they need, I guess, to be able to do their jobs properly?
I would say I probably don't have a good answer, being I work for manufacturing. I agree that we could use a lot more literature. I think it's really a function right now of there's so many new products coming out that the urge to get the product out is number 1, and then getting literature out after that is number 2. So it's like a sales piece and then a catalog and then IOM, and then we get into more of the detailed documents. I don't like it. I mean, I would say I would love to have the stuff available right away too, so I can sympathize with the situation. I would say what I do is a lot of what you're talking about is every day I'm setting up these calls with engineers going through these details, but obviously not everybody knows how to navigate there. So it's frustrating, but I guess that's part of my job is to help go through this stuff, knowing that we do have more information.
Yeah.
So I would say what we do at our firm is we do a lot of factory visits, and we sit down with their application team and we discuss, are you PID loading? Are you on-off offset loading? How does your machine work internally? And then we go back and we write application guides based on the information that we were given. And then we sit down with our engineering firms and we teach lunch and learns, and we try to engage them with lunch and learns and sit there and educate, and also be on every call on pre-design calls and talk about it and make our points of like, hey, this is what the machine's going to do. Do we want to think about switching sequences? Let me educate you with these documentations that we wrote up. If you have any questions, feel free to reach out. Kind of just like sitting down with the manufacturer, getting the information, and then passing it along.
Yes.
In a lunch and learn type.
And the engineer has to be able to do that in the 6 weeks that they have to get the drawing set out. And that's part of the challenge, I think, right? Is like that's great. Takes a lot of time.
Yeah, I think the things we can all acknowledge is that the manufacturing world has been flipped on its head in the last 5 years. We've all had to replace every single refrigerant we've used for the last 30 years and create new products at a lightning pace, fastest I've ever seen it switch over a whole product line. So that, in coupled with the new technology that we're using, has put the manufacturers in a bad spot. I also think that, to your point, the reps are screaming to get the product out, but they're not keeping pace with the product knowledge, and because they can't, because it's not there yet. So it is perfectly acceptable for a consulting engineer to go, Mr. Rep, that's cute, but I'd really like to talk to someone who knows what's going on. The problem I have is a lot of the manufacturers, you go and it looks like their mom drove them to work because they're like 18. So I'm like, how could you possibly know what's going on? And each manufacturer has 1 or 2 guys that are the guy, and it is really up to the rep to know where that guy is. So what I would say is find a rep that knows what they're doing. Find a rep that can get to the right guy, and use them when you have a heat pump job. And then use them to help you get the project off the ground and going where it is. It is not, you guys are the customers. You guys are the consulting engineers are the customers. They can force the issue with the reps, and the reps will listen. So I would say be forceful. Tell them that I don't want to talk to you. I want to talk to the manufacturer. And most reps that are trying to do a good job will get that connected right away.
If you want me to spec your unit, you will.
You're only asking them to do their job.
Yeah, exactly.
Well, and I mean, I liked, I swear we didn't set it up this way, but I think if any of you were there, our intro session yesterday, we kind of introduced this whole series of sessions that we're doing. We kind of got to the fact that the technology is great, but it's people that matter. So it's the people and the relationships. That's how we solve this problem. It's not better technology. It's finding somebody you trust, building that relationship, talking to people. That's kind of the key. Okay, question middle here?
Terms you want them to be more flexible. So what did you mean about this exactly?
So I think.
I'll just repeat the question in case everyone didn't hear that. Asking James to elaborate on his comment about what specifically can the commissioning team do to be more flexible in these projects.
So I said commissioning. I think my intention is as a group we have to be more flexible, right? We've lived in the plans say what the plans say, the specs say what the specs say, the sequence of op say what the sequence of op. We really want the building to be warm, people to be comfortable. That's the end goal. And as long as we keep that in mind, changing what the sequence says as we're going through the commissioning and not adhering to, well, no, this valve has to open when I tell it to you, but causing more problems down the way. So the commissioning agents, I mean, for those of you that work with techs, their number one, especially manufacturers techs, their number one job is not to get a call back about that piece of equipment. That's what their number one job is. They don't want to get a call back. So they will set up at 125 degrees instead of the spec 135 because they won't get a call back at that. Now, the building might not be comfortable. Or we need to talk to the engineer and go, hey, can we get away with a different temperature? And that has to, so when we all need to sit down and be more flexible to allow for changes in specific parts of the sequence, specific parts of the water supply temperature, the flow rate, and all that stuff so that we get a system that works as a group rather than just as that. So that when I tell the commissioning agent it has to be flexible, they're great at making you do everything that's in the specification. Whether or not that's exactly what should be done, that's the different thing. So we really have to keep the end goal in commissioning, the end goal in the design, and the end goal with supplying equipment in mind, that we really owe it to the owner to provide a building that is warm and comfortable and does what it should, but it might not do exactly what the plans say, and we all need to figure out the best way to do that.
I mean, I'll say as the engineer, like the best projects we've had is like we get the chance to sit down with the programmer before they even start writing code. Be like, this is our intent. This is what the sequence says, but this is actually this is what we mean. And they'll be like, well, don't do it that way. Like here, change this, sequence those valves different. We're going to enable the pump differently than and I'm like, fantastic. Like I would rather figure that out now prior to you programming it than having to come back and like change it all after, right? When it doesn't work. So you need, again, to have that sit down and have that face-to-face with them.
The thing I would add to that is our challenge in our region is we do a lot of core and shell projects. So we are called out there to do commissioning and startup on a project that has no VAVs installed in the building. Test and balance is done. And they're like, okay, let's run through our commissioning script. But when we sell a project, we need to know that we're going to have to return to that once we have a tenant in place and we have VAVs installed. And so just be flexible with like, hey, our part load is 17 tons right now, and that'll never happen once we have an occupied building, but we only have a 30-ton compressor and it's crossed the line with no turn down. Well, hey, there's gonna be a lot of cycling going on right now when we do this commissioning, and we don't have the load to load this thing to 100%.
And that goes back to Dan's point earlier about seasonal commissioning. So be flexible about when it is. No, we have to turn over the building. We need our TC, do the commissioning now. Well, great. It's 80 degrees out. It's going to heat the building great, so it just goes back to it's a continuous thing, but really trying to be flexible in all aspects, which is hard because we all need to have the man hours to do the commissioning and whatnot, but expecting that ahead of time, you can kind of build that in.
You got to set up the contracts that way. Exactly. You got to put that in the spec that there's a year. I always say there's a minimum of a year of commissioning, and probably should be more like 5. But if there's no money for that, it's not going to happen, and that's what you see. They do the startup piece pre-tenant, and then that's it. Everyone GC wants off the job. Contracts are closed. Who's going to do that piece when the tenants move in, right? Okay, we'll go there and then over there.
To piggyback on that, I can't get commissioning on half my jobs. The GCs.
Why not?
There's no money for it. And I think it's code required. I don't know if anyone can answer that question confidently.
What's the jurisdiction?
Yeah, it depends on the age.
New Hampshire.
I can't speak to New Hampshire.
It's required in Colorado. That's what I can answer to. I don't know about anyone else.
It's not required in a lot of places, though. I know that.
Could you write it into a spec?
We do. Yeah. But the owner still has to want to pay for it.
Well, and it brings up a great point, kind of related, is the fact that a lot of times these heat pump jobs, the first thing you hear is the plans go out and 5 minutes later it's over budget because people looked at it and saw a heat pump and they decided that it was over budget. And so that is a constant battle in these projects, is keeping the budget in line and trying to really set expectations all the way through. And if you go back to when VRV kind of stormed into the market, it was the same thing. Contractors were didn't know what they were getting into, so they were putting more and more money on, and the mechanical would put more on, and then the GC would put more on, and it was a cascade effect to put the budget way out of whack. And I think we're seeing some of that, right? We don't have money for that because we're commissioning for 5 years, or we're fixing a loop that's gone bad. So it is a struggle, and you can't discount it, but you got to talk about it. And you got to talk about it with the GC. That's great. Someone's going to pay for it sometime. Do you want to pay for it 2 years from now when we're back here commissioning, or do we want to pay for it up front so you get it built into the cost of the job? But it's really difficult, and it is probably one of the number one problems we have implementing these projects.
And they're not like boilers. You can kind of get away with the startup, and then that's it. Like, it's not ideal, but your building will have heat. But I mean, with heat pumps, I would say if you can't afford the commissioning, you can't afford the heat pump. Question over there.
Yeah, Jeff Banta, Siemens Healthineers. So I get the feeling I'm going to be the guinea pig for owner. I appreciate everything you guys have brought up. I've got a couple of different questions, if you don't mind. One is best practices and case studies for successful projects in complex heat pump modular systems that other engineers can use to argue with code officers. Right now I've got a handful of decarb projects taking 60-year-old buildings that have gas-fired boilers that have operated other than maintenance and those issues common to the systems, and now we're being told we have to decarb. Great, fine. Comes down from C-suite, fine, make it happen. We give them information on what it takes and they choke on the cost. The other thing that I'm seeing is common sense has gone out the window.
Care to elaborate on that?
Up until 5 years ago, thermodynamic efficiency ruled. It ruled the finances. The finances governed the projects. Now, it's decarb. Ignore the cost. Ignore the physics. Now, what I hear from you guys, from the industry is you're doing your best, and I get that. But the one thing that I can't do is go to C-suite and champion a project that in 5 years still doesn't work, and they've spent $25 million.
Who wants to take that one?
I'll take the first swing, and then you guys can correct me whatever I say is wrong. So a couple things. We all hear
I know
that every day, and
I'm trying to
it's,
beat up on you guys.
No, it's.
This is the discussion we need to have.
This is the discussion we need to have. So there's certain things that the more you talk about it up front, and here are the 10 challenges, and then you make the decision on what you want to do. Retrofitting old boiler systems is the big leagues. That's the hard stuff. You can build a building from scratch, make it pretty effective as far as cost and whatnot. But when you're going in and trying to replace steam or replace very hot water, you know, the quality of heat isn't the same. But you can get there.
The response is not the same.
We had a couple projects at a, I don't know, want to list them off, but one at a university that was a old steam project, and it was a very challenging project because we went from, you know, pretty high quality steam as far as temperature is concerned to 130 degrees on a large arena, and that took years of engineering to get it done. And it works now. And so it wasn't a 5-year commissioning. It came out, but I will tell you that the team that was involved, and we weren't involved in the project, but the team that was involved, from start to finish, everyone was involved. So I think the retrofit is a really hard one to go, and a lot of them are not being told, not being asked, they're being told to do it. And the other, to add on top of that, finances aren't great right now. So everything is costing more as far as lending and all that other stuff. So we really, it is a hard thing to do. But I would say that the more you can get everyone involved from the TC, everyone on board early, the best chance you're going to have a successful project.
And that's kind of what I'm learning, specifically this week, but it's been in the back of my head the last 4 months, 6 months, is that really we're seeing a dynamic shift in these MEP projects. And when you're talking to C-suite folks that are basically the old guard, right? And they're used to the old gas-fired systems, that's a different design process and project execution process. And me as a project manager, it's incumbent on me to manage their expectations, right? And the one thing that kind of, Matthew, it was one of the things that kind of really bothered me was some of the comments about California code, getting into code-specific means and methods. No, they have no place in that. Set your guideline, let them run. Right? When they get down to the point of speccing equipment or sequence of operations, what were they using as an example? What was their basis of design?
Is your point that the government is inefficient?
We all know the government's inefficient.
I'm
controversial. I don't know. It's a controversial comment there, James.
But no, managing the expectations has to be done up front.
It's the number one thing.
Right. Bringing everybody, and Dan, I really loved your comment, and Brad, yours also, about the availability and the exposure of the systems design engineers to the MEP design guys for coming up with the sequence of operation, the programming based on that building, that operational need, and the equipment that could or not go in. And there's lots of different ways to skin the cat. But there's, the top-down pressure of decarbing, and I know you guys, the manufacturers are catching up, trying to find best practices and good engineering and coding and all that. But
Just to plug a future session, if you're available at 3:00, we're going to have a whole session on retrofits and like big, complicated retrofits. With
I wish I could. I've got an ALI to do.
All right. Well, if anyone else is interested in retrofits,
I have something to add on retrofits. Like, you got to go into the mindset with like VAV coil replacement. Like, it's a very expensive process. Full controls integration replacement. Like, that's all has to be laid out at the beginning.
I am already redoing my schedule and my timeline, looking at longer term seasonal commissioning, having to make the case for that, doing the risk log, just the whole 9 yards, so as to get all of that up front to defend a budget that I know is coming. I shouldn't even say a budget. Right now, they're not really sure what their end cost is going to be. They've got a number in their mind, but they're looking in historical figures, historical projects for estimating. And I've already hit them twice with project costs that have caused them to kind of lose their mind.
and don't use a quantity surveyor either for these costs. Like, go get a contractor.
I have.
Yeah, okay, good.
I have. Already.
You made a comment about common sense going away. I wanted to kind of grab on that. Is for where I took that in my mind is keep it simple. Keep your system as simple as possible that meets the needs of the building. An example, I saw a drawing the other day. It had like 3 centrifugal chillers, 2 free cooling heat exchangers, 2 banks of 2 pipe air source heat pumps, and 2 banks of 4 pipe air source heat pumps on 1 set of variable primary flow pumps. And I asked them, they're like, this is what we're gonna do. I said, how is this gonna work? And they're like, well, that's what we're talking to you for. And I was like,
Perfectly.
I don't know how.
Worked perfectly.
I don't think this is going to work. And so the point is, you can, some of these electrified systems get really out of hand with putting all these different crazy pieces of equipment together, and maybe it makes sense in some case or the other, but I think if you can really try to start off as simple as possible, and also the controls part is a big one too, I think is such an important part of integrating that and making sure whoever does control it knows what the equipment does as well. And that may be meetings upon meetings to get there, but simple and controls are going to be pretty big levers for a successful project.
And, James, I think you brought this up. New construction, that's the easy pathway. You're able to, basically, the MEP can help drive the footprint of the building, right? It's the refurbs and the renos where you're already in a fixed footprint. You only have so much property. Right, you only
might have the legacy of upgrading all your condenser units, and your duct sizes are fixed, and your pipe,
Right, and so some of these best practices, whether they be ASHRAE or code, I don't think they really speak to the installed base.
Well, I think the big aversion we have is to pick the team early, like competitive bid, down to the light bulbs, right? And I think picking your team early is actually the best way to control cost, and getting a team that is qualified is the best way to control cost. And that is kind of a mindset change in our industry. But
100% agree with that.
Design builds are your GMPs are never. It's the minimum price, not the maximum. But we have to get the teams on early with a common goal, and that has to be part of the DNA of the job, or it's not going to work the way they want it to.
I can't remember the last design bid build I've done. Primarily, they've been CMN risks, but a lot of this decarb stuff, I've engaged MEP for the last year on coming up with feasibility options. They're engaging manufacturers and reps and coming up with different ways, at least at, that 30, 100,000 foot level, trying to drill down on what the best cost options are.
And that's all we as a consultant. We only do retrofits and projects like that. And I'll say, we've learned a lot over we're much better at this now than we were 10 years ago. So I think finding folks that have actually done it, I'll just get another brief plug. You asked about case studies at the start. So, I mean, we've published quite a few. They're Canadian. I don't know if that helps you, but there's some resources. But also a design guide. So we did a kind of a 200-page together with some other engineers who had experience in this, and it's kind of intended as a guide to get new consultants who haven't maybe done decarb before. They're used to boilers, used to chillers, to say, okay, here are the things, and running through the different heat pump types, and like, here's the considerations, here's the things you need to start to think about, here's how, and it's all retrofit based. So, you know, here's what your output from your terminal units is gonna look like if you start dropping your water temperatures. So those sorts of resources are starting to exist, but it's early days for sure.
Well, I appreciate your time.
We have 5 minutes left, so we can get a few more questions in here.
Hey, Greg Waldorf, Bighorn Consulting Engineers out of Colorado. You mentioned towards the start that one of the problems, one of the issues you see is systems being designed right at maximum. Energy code tells us that we're only allowed to oversize by 15%. Some jurisdictions are knocking it down even to 5%. What are some steps we can take on the design side to kind of balance out the energy code requirements and not running those systems at their peak?
So first, I the maximum maybe is the maximum envelope of the machine that we're doing. So it's the operating envelope, not necessarily the tonnage. I have very little concern about the BTUs that it produces. It's if we're at X BTUs at 140 degrees and, you know, a large delta T or stuff like that, really pushing the performance envelope, not necessarily the tonnage. So that's what, when I was meaning that don't push the unit, it's not necessarily in capacity, it's more in what we're asking it to do. I don't know if you guys have.
I mean, I guess also it's like, well, in that context, what does oversize at what outdoor air temperature, right? Like your capacity is variable when it comes to an air source heat pump.
And if you're using air source, or even if you're using, you know, like, yeah, do you size it at -5 and really get like 5 times the cooling you need? But you get at -5 design day, you know, or -10 in Grand Junction, you know, like if you design it for that, you're going to way oversize the cooling, and then can the machine even unload at that point? Or at whatever the cross point where the COP gets to 1, maybe you just put an electric boiler in, right? Because that's really the break-even point. So you design it down to 15 degrees or wherever its crossover is, and you get all of that extra BTUs because the hours that you're dealing with, if you look at the bin hours, is way less than the so there's a lot of presentations about right-sizing heat pumps, and I know every manufacturer has one, and they each have their own little sweet spot, but they all say the same dang thing. Is like, if you design it for the most coldest temperature, you're going to way oversize, and you might not be able to unload on the cooling side. Especially in Colorado, we're going to get way more than that.
Yeah, I would say there's a lot to unpack for that, being like, what is the equipment type? And do you have an existing boiler, or are you going to add in a boiler? And what's the role of that boiler, or how you size the heat pump? So I would say there's a lot to dig into on that one, to think through.
Yeah, and I was just going to add, I mean, you said everyone's got the rules of thumb. You know, ours is like, you know, 80% of bin hours is kind of, if we get 80% of the heating hours, and that's, 80% of the energy, and then that's usually, I don't know, our climate, it's down to like -5 Celsius or something, so what's that, you know, 20 Fahrenheit, yeah. And then after that, it's, you know, backup boiler, gas or electric, whatever we have, right? Okay, we have time for probably one more question. Anyone? Answer them all. Yeah, over there. So Mike coming to you there.
My name is Anthony. I'm from Armstrong Fluid Technology in Toronto. I just wanted some clarification on something that you guys were talking about earlier. You were saying that the heat pump should not be controlled, use the set point and let it do its thing. But from my understanding, so you have your set point, and then, you know, you're waiting to reach that set point. it just seems like that's a bit of a reactive approach, and then you're putting a lot of load on the system. I just want to know if you can clarify, why would you be opposed to controlling the heat pump, variably as opposed to just having that set point?
Well, a few things about that is, depending on what manufacturer you're working with, you could do things to speed up staging processes. You could, if it's available point, open modules to decrease your delta T at the machine and get it to react faster. Your staging timers in the machine, and some manufacturers are adjustable. It's really what you're working with.
Anyone else want to quickly comment? Okay. All right. We are at time. Just a quick let you know what else we got coming up today. If you like this session, you may like retrofitting. I'll be hosting that one again. I have some building owners and some other folks who are experienced with kind of big, complicated retrofits. That's at 3 o'clock. In between, we've got a session on cybersecurity, which on the control side should be pretty interesting. But yeah, join me. And then at the end of the day, we have Phil Zito from Smart Buildings Academy. He always does a fantastic job on smart building topics. But yeah, join me in giving these guys a big round of applause. And thank you for coming.